Okay, so here on page 70, we see that here, just like the graph that we drew, the graph is 1 over x. It's called a rectangular hyperbola. F of x equals 1 over x is undefined when x equals 0. So as you know, when x equals 0, that is the same as the y-axis. And when x equals 0, we can't divide by 0, so it would be undefined at that point. The graph of 1 over x exists in the first and third quadrants only. So here in the first quadrant, and here in the third quadrant, just as we drew. And it's symmetric about the line y equals x. So if we were to take this line and reflect all the points from this side in a perpendicular fashion into this line y equals x, then the graph would appear over here. And if we were to do the same thing over here, these points making up this part of the graph and reflect them in a perpendicular manner into the line y equals x, those points would then appear over here. So this is symmetric about the line y equals x, and it's also symmetric about the line y equals negative x. So again, if we were to take all of these points from this side and reflect them perpendicularly into the line y equals x, all those points would show up over here to form this branch on this side. And another characteristic, as x approaches positive infinity, as x gets really, really large, we see that f of x, the function itself, approaches 0 from above. And when x approaches negative infinity, when it gets really, really large in the negative aspect over here, the graph approaches y equals 0 from below. And so that's discussing the behavior of the graph around the horizontal asymptote. Now if we look at the behavior of the graph around the vertical asymptote, we see that as x approaches 0 from the right, so as x gets really, really small, approaching from the right, the graph is going up. So it's approaching positive infinity. And then as x approaches 0 from the left, we see the graph is approaching negative infinity, as stated here. And the asymptotes of f of x equals 1 over x are the x-axis, that's the horizontal asymptote, and the y-axis, which is the vertical asymptote. Okay, so let's move back here. Go to the next page. So let's take a look at horizontal asymptotes. So for the function ax plus b over cx plus d, we're going to take a look at these functions. And notice that this graph, f of x equals 2 over x minus 3, is this graph here. As x gets really, really, really big, notice that the graph is approaching a certain y value. So the function is approaching some y value as x gets really, really big positive and really, really big negative. That is actually the graph, or the line that the graph is approaching is called the horizontal asymptote. And in this case, is approaching the line y equals 0. When we look at x plus 1 over x minus 3, again, as x approaches positive infinity or a negative infinity, it seems to, both of them sort of level off at a certain y value. And in this case, it happens to be right about here. So the equation of that horizontal asymptote is y equals 1. For the graph here of 2x minus 3 over x plus 1, again, as x approaches or gets very, very big positive or very, very big negative, again, the two branches level off at a certain y value, which happens to be this one here. So the equation of the horizontal asymptote is y equals 2. And then again, we'll look at the same thing over here. As x gets really big positive or really big negative, the graph is leveling off at a specific y value. Here we got to make sure we take a look at the scale. Here is negative 1 down here. That's negative 0.5. This is 0. So it seems to level off right here, which is at negative 0.25. So the equation of the horizontal asymptote is y equals negative 1/4. So now, if we're to take a look at this, when we're looking at really large values of x, like huge values, like greater than 10, greater than 100, greater than 1,000, greater than a million, greater than a billion, greater than a kajillion, this -3 right here won't make any difference to that huge number. So it's like if we were to take $3 away from a very rich philanthropist. If we take $3 away, he may care because it's not very nice, but he's not going to really notice any big difference in his bank account. So we can kind of just ignore that. Same thing here, if we add $1 to a really huge bank account, that dollar won't really make a big difference in the total. Again, same with subtracting 3. If we take a really huge number and multiply by 2 and then subtract 3, that subtraction of 3 won't make a big difference. Just like here, if I change the analogy a little bit, if we add 1 drop of water to a pool of water, that's not going to make a big difference in the level of the water. And same thing over here, subtracting 3 from a really huge number is not going to make any difference, and same with that plus 1. So all these things, because we're dealing with such huge numbers, those adding and subtracting of these minor little numbers is not going to make a difference. So now if we go back over here and evaluate the first one, we've got 2 over a really huge number. So if you want to work that out in your calculator to see what number that would be approaching, that is approaching something very small. So 2 over 100, 2 over 1,000, 2 over a million, 2 over a billion, that is effectively approaching 0. Now when we look at this, we're left with y equals x over x. And x over x, we can just simplify down to 1. If we have 2x over x, that simplifies down to 2. And when we have negative x over 4x, that simplifies down to negative 1 over a quarter, or 1 over 4. So notice how the ratio of the coefficients is equal to the horizontal asymptote in each of these cases. Okay, so that's all we really have to worry about in this case. So we want to use the coefficients in the numerator and the denominator to find the equation of the horizontal asymptote. Therefore, the equation of the horizontal asymptote for f of x equals ax plus b over cx plus d is y equals a over c, where of course c cannot equal 0. Okay, so what we're going to do is we're going to complete an example on the following page. Then I'd like you to come back to this and use the disk, the software, to do investigation 2 from your textbook on page 70 to 71. Read the information shown under this heading, rational functions in this form. Not just read, but read and synthesize and analyze and memorize. And then complete the investigation 3 of finding asymptotes. Now we're going to do kind of all of this stuff on this next example, but I'd like you to go back and review this afterwards anyways. So let's move along.